is a phenomenon whereby a body changes its position with respect to time and space. The phenomenon where a body changes its position with respect to time and space. So if I have a body, let's call it A, placed at this position, and I apply a certain force in that direction, that body will change its position to point B. So because this body has moved from point A to point B, we say it has undergone motion. So motion is the change in the position of a body, in this case from position A to position B, with respect to time and space. So time is involved in motion, and then there's a change of position also in motion. That's the space we are talking about. Now, we move on to types of motion. Now, under types of motion, we have linear motion, we have circular motion, you have projectile motion, you have random motion, you have oscillatory motion, and of course, you have what we call the simple harmonic motion. But we are going to be considering linear motion in today's class. So what exactly is linear motion? Linear motion is the motion which follows a straight path. So any motion where the object in moving from one position to another undergoes a straight path, we call that a linear motion. So if a car is moving along a straight road from one point to another, that car at that instant is undergoing linear motion. Likewise, a train along a straight track is undergoing linear motion. And then myself, if I move from one position and then I move to the next position in such a way that my movement is straight, what am I doing? I'm undergoing what? Linear motion. So linear motion is motion that follows a straight path. Now let's look at what I call the parameters of linear motion. Parameters of linear motion. What do I mean by parameters of linear motion? I'm talking about those things that help us to understand linear motion, that helps us to break it down in such a way that we can now be looking at different areas that has to do with linear motion. So those are the parameters. Now, the first parameter of linear motion is distance. Distance. What is distance? Distance is simply the amount of space between 2 points. Initially I mentioned that when an object changes position from a given point, or in this case A, to another point, we say that object has undergone motion. But if we are now measuring the amount of space between A and B, then we talk about distance. So distance is simply the amount of space between two different positions. The amount of space between two different positions or points. That's distance. Now, the second parameter of linear motion that we want to look at is displacement. Displacement. What is displacement? Simply, displacement is distance covered in a specified direction. Distance covered in a specified direction. So again, if I have an object at position C, and then that object moves along that path and then stops at position D. Now, if I'm asked to take the amount of space between position C and position D. That space between C and D is distance. I hope we're getting what I'm explaining here. So from position C to position D is distance. But when we are talking about displacement, we're looking at the distance in a specified direction. So if from position A, C, I now move straight down. Now that's a specified direction. I can actually get the bearing of D from C. It will give me a certain angle if I were to get that bearing. So I would know the angle at which D is located from C. That's a specified direction. So when you are measuring distance in a specified direction, you talk about displacement. So to explain that better, if I say the distance between C and D is, let's say, 4 meters, that's distance. But if it's displacement, I have to specify the direction. 4 meters due east. So D from C is 4 meters due east. This is displacement. This is distance. So distance just measures the amount of space between 2 points, but displacement measures that amount of space while considering the direction in which the measurement is taken. So that's displacement. Now let's look at the next parameter of linear motion, and that is speed. Speed. What is speed? When we divide the distance between 2 points by the time taken to move from one point to the other, we talk about speed. So speed is distance moved or covered over time. Speed is distance over time. Now, the unit of distance is meters. The unit of time is seconds. So it means that the unit of speed is meters per second. So again, speed is distance divided by time. When you measure the amount of space between 2 points, the distance between those 2 points divided by the time that it took for the object to move from one point to another. When you measure and you divide the two, we call it speed. So that's another parameter of linear motion. Then the next one we are looking at is velocity. Velocity. So speed. Number 4, velocity. What is velocity? Velocity is defined as displacement over time. Displacement over time. Don't forget I told you earlier that displacement is simply the distance moved in a specified direction. Now, if you divide that displacement by the time taken for the object to move from one position to another in a specified direction, what you have is called velocity. Now, the unit of velocity, just like speed, is also meters. This is meters, this is seconds. So the unit of velocity is meters per second. So it has the same unit as speed. But like I explained, speed has to do with distance covered divided by time, while velocity is displacement divided by time. Both distance and displacement are measured in meters or kilometers as the case may be. Then time can be measured in seconds or hours as the case may be. So you can have meters per second or kilometers per hour as the unit of either speed or velocity. So the last parameter of linear motion we're going to be considering today is what is called acceleration. acceleration. So let me write that one down. Acceleration. What is acceleration? Acceleration is defined as velocity change over time taken. Velocity change. When we say velocity change, think of it as a vehicle that is starting from an initial velocity. Think of a vehicle, for example, now maybe you are driving a car out of the garage in your house. Yeah, by the time you hit the road in the neighborhood, the speedometer might be reading 20 kilometers per hour. So we can call that one the initial velocity. Now, as you move out of the neighborhood onto the main road where there is little obstruction, you would definitely want to step on the throttle, the accelerator, and that would increase your velocity to, let's say, maybe 40, 50, depending on how good or how smooth the road is, and then the obstacles. So because you have moved from a lower velocity to a higher velocity, you have done what we call accelerated. So when you are now asked to calculate the acceleration, you will just subtract the bigger velocity from the smaller one, which is called velocity change. You now divide it by the time taken, and that will give you the acceleration. So acceleration is velocity change. That's the increase in velocity. That's the new velocity minus the previous velocity divided by the time taken to move from the previous to the new velocity. So when you divide the two, we have what we call acceleration. Now, the unit of acceleration, this is meters per second, and this is second. So by the time you divide meters per second by second, you are going to have that the unit of acceleration is meters per second square. So today we have looked at what motion is. We also looked at what linear motion is. Then we have looked at the parameters of linear motion. I believe you have understood one or two things today from today's class. See you in the next class. Thank you.